Welcome back, computer. We're here again. Hello, everyone. It's time to continue our journey, as promised, into our quest, I guess you could say, of writing a bot to play Pokemon Emerald. Today, I think we're going to approach things from kind of the opposite side. So I guess a summary of the journey thus far is we've built a little bit of integration on the kind of technical game integration side, where we've done some reverse engineering to find some memory addresses so we can read some relevant information from the emulator. I think this time we're going to do a little more. So if we consider that kind of the legs of the project, we're going to work a little bit more on the brains. So I've been inspired to, I've been doing some reading about how things like damage calculations work in Pokemon. So I think we're going to go on a deep dive into some of that fun stuff and maybe implement some things. And I don't know, maybe talk about ideas for writing a decent AI. Things along these lines and other things as well. So I guess without further ado, we'll hop right into it. So, how to begin? I'm gonna grab some water. The power of thirst quenching. So, let's talk through what we need to write an AI that can reasonably. So we're not going to consider the AI that needs to like navigate the game and move around the maps and things like this, because I think a lot of that's going to be hard coded to like, well, or maybe we're going to have like a set of coordinates as objectives that are like, okay, navigate to this point, talk to this NPC, navigate to this point, talk to this NPC, etc., etc. But a lot of it is going to be like kind of manual, right? Because I don't think we're going to have a bot that like discovers the course through the game. On the other hand, something that is sort of an interesting AI task is winning battles, right? And that's something that we can sort of test easily as well once we have a decent AI and integration with the game, because we could build something simple like a Emerald has the battle factory, so you can enter a facility with a random team of Pokemon and kind of like keep trading up as you win, but like ultimately it's just battles. So you can play without really having to consider the rest of the game at all. We can probably just warp to the battle frontier, hop into the battle factory, do a bunch of battles, see how our AI works, and go from there. And that might be like a good outcome. Like, I don't know, like if we build something that's like can decently can clear the battle factory very consistently, and did we lose the stream here? We're live, right? We're live. We're going. We're moving. We're schmoving. Okay. I think my my stream monitor machine decided to briefly kick the bucket. But yeah, so we'll build some AI that can think about Pokemon battles. We'll talk about, well, probably this stream we'll mostly just investigate what we need to simulate Pokemon battles, which is an important part of writing AI, and we'll talk about why that's the case. We'll kind of think about the architecture we're going to use for this whole thing and do a lot of learning together. And yeah, let's hope it's lots of fun. So let's start by talking about kind of the general way I want to think about the AI for this thing, and then we can think about what we need to build. So kind of I think a relatively well kind of I don't know, well-known classical game playing AI technique is tree search, right? So let's use chess as an example, right? And this is we'll later extend this to Pokemon battles because it's a little more complicated. So chess, you can kind of consider chess as like it's a turn-based game, obviously, right? And you're alternating between two players. Each player has some number of moves available to them, and each move changes the state of the board, right? And the state of the game is captured by what the board looks like currently, right? There's no hidden information. You just have a very clearly the board is the state of the game. You alternate making one move at a time that alters the state of the game in a predictable way. So you can sort of consider, if you think about a tree, right? You can consider a tree of game states, right? Where the nodes in the tree are board states, right? Game states, and the edges, right? The children of each node is a tree, are moves that can be made by the active player from that state, right? So in chess, there are a whole lot of different moves, right? You can move each piece, right? Every move for every piece, right? So it's quite a lot. Certainly more than the number of pieces on the board, right? Because, like, for example, your knights can move a whole bunch of different ways. So kind of one way you can do AI, right, is you compute this tree, right? And then every time you have to make a move, you navigate down the tree such that such that the move you pick leads to the subtree, the child tree, with the most wins, right? So you're kind of maximizing your own chance to win, because eventually the tree ends, right? Because some board states in chess, like checkmates, are wins for one player, right? And there's other rules for draws and things like this. I'm not a chess pro, right? I've played a little bit of chess, but so you can sort of imagine this tree of states and moves, which are transitions between states, and then just sort of like maximizing, playing the most winningest move always, right? To navigate this tree down to the bottom where you win, right? This sort of algorithm will play perfect chess. I think this is called Emacs, right? Let's hop on Wikipedia to guide our thinking a little bit here. Emacs here, yeah. So this is probably a little more complicated than the thing I'm talking about, actually. Oh, maybe not. So this is basically every like turn you are maximizing the minimum gain, right? So this is one kind of mode of tree search, right? You're searching a tree for the wins. The problem with this, right, in the kind of the purest form, right, is that this is untenable, right? There are a whole lot of moves in chess, right? And a chess game might go for, I don't know, you're playing for many turns, right? So like the size of this tree grows exponentially with the number of moves, right? So like if you have 20 possible moves and your chess game is, you might predict it's going to be at least like 30 turns long, your search tree suddenly has to be like at least size 20 to the 30, which is not super tenable, right? We can't do that. We can't just enumerate, if the game is large enough, we can't just enumerate all the possible moves, right? So there are techniques to make this a little more tractable, right? So you can do something called pruning the tree, right? Which is basically just saying, okay, some paths are so obviously not it, right, that we can just throw them away entirely, right? There's also you can also limit the depth that you search into the tree, right? So instead of searching all the way to the bottom and like examining the like the actual winning and losing board states, right, you can write something called a heuristic, which is a way to assess a given board and determine, okay, like, am I winning or not, right? So and then then instead of having to search 20 moves ahead or 30 moves ahead to get to the end of the game, you can limit yourself. You can say, okay, I'm going to search 5 moves ahead, right? And then at that point, I'm going to assess all of those board states and see which ones are best, and then route myself towards the best, right? Which so this naturally, right? Like since you're only looking 5 moves ahead, right? Like this sort of analogy is very nice for chess, right? Because in chess, it's like, oh man, like there was a mate in 15 moves, right? You have to look very far ahead in chess in order to find the right lines. Sometimes, like they don't look obviously correct for many moves in the future. So obviously limiting your AI in this way, like will worsen your performance in terms of game performance, but it's going to better your performance in terms of like, can I actually run this thing on a computer? You might imagine a lot of this maps super naturally, right? This sort of tree search approach, right? Like you can very easily map this to Pokemon battles, right? Pokemon battle, it's a turn-based thing, right? Each person picks a move, then those like, so it's sort of slightly different from chess in the sense that moves are resolved simultaneously, right? So you and your opponent both pick a move, and then the game kind of resolves them, right? For example, things like you can't be sure whether you'll go before your opponent, for example, right? Like, of course, there's like the speed stat, which is hidden information, and there's things like, well, if like you can switch out, which normally goes first, but if your opponent uses pursuit, like there's things like this, right? There's nuances, right? So I think it's most natural to think of it as you and your opponent both blindly submit a move, right? Not knowing what the other person picks, and the game resolves that combination of moves to produce a new board state. So that's interesting, right? And then another element that makes Pokemon a little different is there's randomness, right? There's uncertainty. Which is interesting. Like beyond, like, of course there are moves with effects, right? Like if you use Scald or something, right, there's like a 50% chance to burn, right? So whether or not that burn applies is both relevant to the outcome of the game, and also like that's something that's not present in chess, right? So we have to think about how to model something like that. And even kind of more so than that, there's a variance in the amount of damage that particular moves do, right? I don't know exactly how much variance. I hope we'll learn that a little bit today, but there is variance. So you can be in situations where a move might defeat the enemy's Pokemon, or it might not, right? So like if you're predicting 4 moves ahead, right, and you end up in a situation like that where, well, you think you can use a move and it might defeat the enemy's Pokemon, what do future states look like? What do 5, 6, and 7 moves ahead look like, right? We suddenly have a, like, the opponent's Pokemon is probabilistically alive, right? Or not fainted, I guess is the correct term, right? Like so there's nuance here, right? And I'm not sure how to handle that nuance, right? I'm not an AI expert, right? I'm not an expert in much of anything. So it's figuring out how we handle this, right? Because I'm sure there are existing approaches out there. I think we can maybe dig a little bit, look at some papers, look at some Wikipedia articles, try and muck our way through some math that probably poorly, but maybe we can do a good enough job to get something reasonable. Yeah. So that's what we'll do. But I think, and of course, we'll probably end up using, even like I mentioned that there were kind of adaptations of tree search, like for using heuristics, right? Tree pruning the tree, things like this, right? And there's also a cool thing called, let's see, Monte Carlo tree search, which is, it's sort of like a probabilistic tree search, right? Not probabilistic in the same sense that, like, I don't think this gives us anything for free to help handle our like randomness in Pokemon, although maybe it does. We'll have to figure that out. But it's sort of a nice heuristic model, I think. Is the utility of this, right? So I think the core principle is you kind of do random sampling, right, where you like simulate one random path until the end of the game, right, and you like do a bunch of these things which are called rollouts, right? So like instead of trying to like exhaustively iterate the tree, right, you kind of like form a model of how different subtrees behave by like random sampling like complete games from that point, I think. Yeah, and as the summary here says, right, in each play out, the game is played out to the very end by selecting moves at random, right? So you play a bunch of random games from the subtrees and guess like, okay, well, in this subtree, X number of random games won. In this subtree, you know, it's more complicated than that. And there's like some math for like better estimating which subtrees are better that I don't fully understand just yet, but maybe we'll come to understand. So we'll maybe dig into this a little bit as well. But I mean, kind of first, the things that we'll need, regardless, we will at least need a decent simulator for Pokemon battles. So that's a lot of fun. So I think what we'll start off with is we'll dig a little bit into how Pokemon battles work in Generation 3. We'll build some models, right? We'll build like a little representation of Pokemon and of turns and how turns are resolved and how damage is applied and things like this. And we'll see where we go from there. So let's see. So I think the first thing to do is let's open up Bulbapedia damage. I think there's a page. It's called damage. Let's hop down to the Generation 3 section. Yeah, so this is going to be the core of our thing here, I think. We have this big formula for computing damage from a variety of variables, right? Move power and stats. And I was actually surprised. I didn't know that like level was directly included in the damage calculation. Things like this, right? It's big, huge formula. Not super scary, right? Mostly just a bunch of multiplications. Yeah, we're gonna see how it all works out. So let's what are we gonna do? Let's hop over here and let's set up a little project for ourselves. I think we're going to write this in Emacs Lisp because it seems pretty fun. And we have a good way to look things up because Emacs has great inline documentation. And I think, I don't know, it's just cool to do things with Emacs. I don't think this is going to be like a super, like, well, eventually this thing is probably going to be like somewhat performance constrained, but like being like starting off in like a not super performant environment, right? Like I mean, worst comes to worst, right? If we hang Emacs to the point that I have to kill it, it's going to kill the stream because Emacs, this same Emacs instance is my window manager, so it's going to cause some problems, right? So we have a direct incentive, right? We are programming under duress, if you will. So that might help us along a little bit, if or maybe hinder us. So what are we calling this? Let's call this I don't know, something. Well, we already have this Smaragdus thing, which is where we're doing the rest of the emerald botting stuff. So maybe we'll just have some existing eLisp code for like doing a bunch of assorted stuff to connect to the game that I was thinking about, like network stuff. It's basically mostly just a netcat. You can also render the map that we're getting out. I've been playing with some stuff, but this isn't. Maybe we'll just do it here. That's fine. Do we have Outshine? We do. Yeah, let's close all of these sections for now. We're going to make a new section called Battle AI. And here we're going to build our Battle AI. Let's make sure all this is eval to. Cool. Some water. I'm thirsty this evening. Cool. So let's start with what do we know we need to represent, right? We need some representation for Pokemon, right? We're gonna make some structs. Is there a def struct in eLisp? It's not a promising start. I always forget what the thing is, right? We're writing this. We could just build everything out of CL def struct. We could build everything out of lists, right? But that gets kind of tedious fast trying to remember whether something is the car or the CADR or the CADDR. So we'll do it like this, right? Here we'll say this is a battle Pokemon. What's our documentation for this? Your name, representation of Pokemon within a particular battle, right? I'm using this abstraction rather than, like, I don't know, we could call this Pokemon, but like I think we're probably gonna have some battle specific stuff in here, right? Like current boosts, right? Which is stats, etc., right? Like whether flash fire is active. Let's even call this let's go even further. Let's have different structs for let's have just a plain Pokemon struct. On stats. Let's have a Pokemon struct and an active Pokemon struct of an active Pokemon. I don't know, these are not super useful comments. But that's fine. So when we're gonna namespace these because that's how we roll. So this thing wants slots. Slots need to either a symbol or be S name, S default, S options. So I think it's mostly just a bunch of symbols. So Pokemon, let's start with I don't know, maybe I think we don't want to be like, well, how restrictive do we want to be, right? Because we could represent things like type here, right? Say like type 1, type 2, right? Or we could have like a species thing that references another struct that's the particular species, right? I think the species thing is fine, right? Because like let's kind of make things as clean as we can. Species. So a species, what does a species have? A species has base stats. It has two types. Let's start with name. It has a name. It has two types. Up to two types, so we'll have one of them be nil if I don't know if S defaults I don't know if we have to specify nil as a default or no, but I'm sure we'll learn very soon. What else does a species Pokemon have? It has base stats, right? So it has we have what are our Pokemon stats? Attack, defense, HP, attack, defense, speed? Yeah, I think something like this, right? And what else? Is there anything else that's relevant? Oh, ability. I don't think we want, like, ability can vary. Or are there multiple abilities possible in Gen 3? Let's see. let's figure this out. Let's probably get there from Flashfire. Flashfire open. Thank you. You're not going to be cooperative? That opening on my other screen? No? Well, we'll just click through. Ability. List of... We want to see how the thing works in Gen 3. Cool. I assume things have two abilities sometimes, right? Like, so that's... Maybe we attach... Well... Let's just say ability 1, ability 2, and we'll have something that selects these, right? Is there anything else we need to care about as far as maybe number as well? Sure, let's try that. I don't know why we're getting some warnings here. Do we need to... I think there's this CL library, right, which is a bunch of like common Lisp stuff. Yeah, so CLlib is the new way to do this. I never know exactly why I'm being yelled at by some of these errors. Okay, this is probably fine, right? So now we have a bunch of stuff in scope. Let's open Lisp repo. So we should have something like Magdus species. It's probably something that makes a constructor. Do we have a constructor? Let's see. Maybe not. Let's see what CLDestruct gives us. Make. Oh, that's unfortunate with our prefix, right? So we need to have options to change the constructor name. Let's do that. Where is this? Because so the name of this thing is going to be I like to use this kind of slash convention for namespacing in Emacs Lisp, right? But we're going to end up with like a constructor that's called make, right? See, so this is sort of ugly, and there are ways around it. We can say this takes a form like this: name options, right? We say conq name. This will maybe give us some information on, uses the prefix for the, no, constructor. Yeah, cool. Our constructor, maybe the symbol, Magdus, make species. This needs to be in a list itself. Okay, that seems fine. So now if we go to here, we should have Magdus make species. Yep. This has a bunch of keyword arguments, right? If we just make one without, yeah, they all default to nil, right? Cool. And we can say things like Smaragdus species ability 1. Give us nil. Cool. So we just have a little record. That's fine. That's what we're looking for. We don't want anything fancy. Let's do our constructor magic here as well. Pokemon and here as well, just to be nice and consistent. Right, so particular Pokemon, this is like one, like not necessarily in battle, but one Pokemon just out there, right? In your party, let's say, has a name, has a species, has, what else does it have? Has a nickname, maybe. I don't think this matters particularly, but it might be fun. Has a gender, has an ability index, right? Which should be, or as, let's just say it has an ability, right? Which will either be ability 1 or ability 2, right? Well, let's denote that. Either ability 1 or ability 2, right? And we'll use this to look up the particular thing. Maybe we should make this even more. If we make these species, is that a symbol? Yeah, right. We can make them the actual function symbols, right? And then it's very easy for us. We just call this function on the species. Cool. Sure. Or maybe like this, and we'll do a little bit of string concatenation, right? Just to make it so if we print things out, it doesn't have like namespace specific stuff in it, right? But it's still, we're still gonna cheat and do what we want. So we have EVs. What do our EVs look like? We have IVs too. Let's think what we want those to look like. Do we want fields? Do we want just a list? Maybe, I think we actually want this sort of like def struct stats, right? And stats is just going to be kind of a generic like way of associating the 6 Pokemon stats, right? We can call this base stats. That's cool. That's cool. And then we can just use, we can have EVs, IVs. These are just going to be stats, right? We can do like the type thing for documentation, I think, right? We can say something like, is this going to complain at us? Let's see. Type. Can I just give the Smaragdus stats? Oh yes. Do that kind of thing. What is this whining about now? Well, probably easier not to. I think we don't, it's not going to give us any kind of like assurance, and we can know from the name that's a stat, that is a stats struct. Cool. So a particular Pokemon has a name, nickname, species, gender, which ability it has, some IVs, some EVs. Oh, it has a nature. Nature. Of course, if I was writing Haskell, we'd be doing a lot of modeling, like inbreeding all the natures as it's a big sum type or something like this. But we'll just use symbols for that, right? Why is our formatting so strange here? We've become so wide. Let's get narrow. Not spaghettified, but just narrow. Cool. Also, chat is occupying an unfortunate amount of screen real estate. There, back to normal. So, yeah, we're gonna ride free a little bit, free ball it, and just use symbols. Is there anything else of relevance? I wonder. Is there anything here? I guess level, right? That's a thing we maybe care about. Let's sort these into some kind of reasonable order, right? These things are sort of mostly cosmetic, but I guess still not entirely cosmetic, right? Like gender matters for attract. Species is pretty critical to everything, then the rest, right? Kind of in order of, I don't know, not really in any specific order, but that's fine. So I think we'll start with that. We'll add some more things, I'm sure, that we forgot about. What else then, right? So here's the active Pokemon, right? So an active Pokemon as Pokemon, it has current HP. Well, let's just describe this in, we'll have boosts, right? Boosts will be another one of those stats things, right? So all of the stats other than HP in boosts will be like in the range between like +6, -6, or whatever the range is for like swords dancing, you know, things like this. And then HP, because you can't boost HP, will just be the current HP. So let's do that maybe, or maybe it makes sense for it to be like the amount of HP loss or some, whatever. It doesn't matter. Doesn't particularly matter. But we're going to encode like the current active battle stats here. Well, actually, maybe we should just have current HP and boosts separately, right? Because boosts, like, we're gonna want to wipe boosts whenever there's a switch that's not baton passed or whatever. It's fun to talk with these things because there are so many endless edge cases, right? Like every possible situation, it's like, oh geez, like well, that holds, but like not when you use this particular move, which is fun. That's part of what makes it fun. But we're gonna have to think about a lot of those things and carefully orient our design around handling them instead of becoming this huge kludgy mess. Cool. So that's what an active Pokemon looks like, right? So when you're battling, right, the state of the game is each player has one active Pokemon and up to 5 kind of benched Pokemon. When you switch, right, like we pull this Pokemon thing, which never changes, or well, this does change, right? So we need what this current HP not lining up with active Pokemon, like kind of nicely, not lining up with boost nicely, tells us is that we're actually missing an abstraction, right? Because active Pokemon is kind of, we're encoding the things that, like, there's a difference between a Pokemon that's active and one that's on your bench, right? Because the one that's active can have things like boosted stats, it can be confused, it can be etc., right? It can be leech seeded, right? All this stuff, right? A bench Pokemon can't have that stuff happen, right? But it's not quite like a Pokemon that's just like in your PC, right? Like you can have status conditions, right? Its HP can be decreased. So let's make an abstraction for that. Let's call this a battling Pokemon, right? These are sorts of things people would like, OOP people would be like, well, just this is a case for inheritance or whatever, but like, I don't think it necessarily is, right? I think our kind of composing approach of these structs is maybe going to be a lot less painful for us in the long run, right? So what inheritance does, right, is it sort of makes it so kind of the Pokemon part of an active Pokemon, right, is not like as much of a first class thing. It's like harder to like kind of swap it out in the fly, right? Which is something we're going to want to do. So I think this is fine. So a battling Pokemon of a, let's just call this maybe bench. or battling is fine. It's both active and benched. And we'll say this is the active Pokemon. That seems like a reasonable perspective. Okay. So it has a Pokemon, has a current HP, and it has a status condition. Sure. Then an active Pokemon will have a battling Pokemon, and it has boosts, and it has sort of let's call this effects, right? This will be a list of effects that can happen, right? Unlike status, right? These are not like exclusive necessarily, right? You can be confused, you can be leech seeded, you can be I don't know, what is cursed, right? Things like there's all sorts of bullshit, right? You could be diving or digging or flying, right? There's lots of nonsense, right? You could be in pedal dance or outrage or some move that locks you into things. You can be biting. Like there's a whole host of things, right? And we'll kind of just have this list and deal with what comes, right? It might turn out to be easier to have a bunch of individual flags here instead of this generic effects thing, right? I think actually it almost certainly will be easier, but we'll cross that bridge when we come to it. Cool. So let's see. Let's just eval this buffer again to make sure we're up to date. Okay, so let's continue modeling out the data, right? Like when I'm doing things, I really like to get a firm grasp of all of the types involved first, right? And then kind of like go from there to like, okay, what's the general shape of the transformations on those types, right? Like, okay, we know how we represent Pokemon. We like maybe next we'll represent the state of a battle, right? And then we know, oh, we just need to map from the state of the battle into the next state of the battle, giving them 2 moves or something, you know, like we're gonna really like model out the problem before we get into like actually coding. So we lots of def structing for now, I think. So okay, we have an abstraction for an active Pokemon and a battling Pokemon. So what's a team? A team is, let's call this team. A team, or make team, excuse me. Team has, this is the rep of one Pokemon team. The team has an active Pokemon. Let's call this active, let's call this benched. So this will be a list of battling Pokemon. This will be a single active Pokemon. And then what is the state of a battle? Let's call this, what's a battle? Okay. A battle is, let's do our documentation given of a battle state. A battle is 2 teams, right? Team 1 and team 2. And active team, which will be either 1 or team 2. Let's add some actual comments to like things that are less clear, right? Like list of up to 5 benched Pokemon. So we have both teams, the active team, and then other things that are sort of like maybe like sort of less visible, like things that aren't specific to one Pokemon or one team, right? Things like the weather, right? We want to know, oh, this is reminding me when I thought about sandstorm, right? Like sandstorm is a weather condition that's doing damage every round, right? What's the opposite of that, right? You can heal every round. That's from leftovers, right? I think notoriously important item in Gen 3 Pokemon, because there are not many other good items from what I'm aware of. So let's toss, that would be on battling Pokemon, right? It's not like kind of intrinsic to the Pokemon, right? But is, and it can change during a battle because knockoff is a thing, and swap or whatever other item manipulating shenanigans exist. Cool. So we have weather, right? There are also another like a bunch of kind of like ambient, non-Pokemon specific things that can occur in a battle, right? One that I'm thinking of is like future sight, for example, right? Future sight is like, I don't even know how future sight works. I think also Doom Desire is like a similar sort of thing, right? Where like it hits in 3 turns, right? And it hits with the stats of the thing it was originally used against, right? So if you use Doom Desire against something like that has really low defense, right, and they switch out, it hits as if the new thing had very low defense, right? Something strange like this, right? I sort of think we want like this, like we'll call it just effects for now, right? This sort of generalized like, well, we might have some other shenanigans going on here, but we don't quite know what they are yet, and we'll expect this to change in the future. We're leaving a little room for Jesus here. Cool. Let's think then. So, well, there is no active. What am I saying? There's no active team, right? This is the whole difference from chess, right? We don't have an active team, right? We have just the 2 teams, right? And moves are made simultaneously, so we don't need that at all. Okay, does this capture what we think a battle is? I think so, maybe. We have a notion of which Pokemon is out, like which is. Well, we're handling single battles here, but let's stick with single battles for now. We have a notion of like what the current status of each Pokemon, both active and on the bench, is, right? We can capture boosts, we can capture status conditions, etc. We have a model for handling weather, and also like ambient field conditions, and also things like Leech Seed and Curse and all this kind of stuff. So how do we handle an actual battle, right? So here's where we really want something that's like a sum type, right? But like let's also have an abstraction that is, well, I want to have something that's just like, okay, here's what a move is, right? But I have a feeling that so much of our like move handling is going to be like so ad hoc. Well, maybe not. So let's see. What is a move? Let's call this a move. We'll have make move. Representation of a move. Right? Because this is also something that we've been completely ignoring in our, let's actually move this up, right? Because this is something we're not capturing at all in our like kind of probably the most important thing about Pokemon, right? Like what moves do they have? Like that's we got to know that. And right now we don't. So let's see. We have a move. A move. You know what, let's just kill all these doc strings, right? Because Emacs isn't complaining about it, right? And it's not like these aren't telling us anything, right? They're only muddling the mixture here for us. So I think we'll drop them for now. So what is a move? A move has a name, probably also a number. Let's have that for posterity. In case I'm thinking we have these number fields, right? Because we're probably going to get the move as like the move index when we actually communicate with the game, right? So we'll think ahead a little bit and make sure we have those fields around, right? So when we do like a bunch of data entry, I hope, please God, that we're not doing manual data entry for moves, but like we probably will be at least a little bit. So I don't know. Well, move has a number, has a name, has a type. It has a power, right? Which we can just have be 0 or nil or something. And it also has like effects, right? So we could write like a little domain specific language kind of, right, in like lists of symbols that describes what effects a move has, right? Or also, honestly, why not just have like a function, right, that describes what the move does, right? So function right. So this is going to map between our kind of like battle states, right? We'll just have some for every move. We'll either have nil here probably, or a function that, or maybe we don't even want the power abstraction. Well, maybe we do. I think there might be some things that care about like move power, like beat up a thing. Like I don't know. This game's complicated, man. But maybe we need to record that. But in general, we'll have this effect thing. And probably the thing that it does is probably the way moves are applied is going to be we first deal damage equal to the power, and then we apply an effect if this is not nil, right? And we only deal the damage if this is also not nil. Of course, like doing the appropriate damage calculation based on the type and all that other bullshit we saw in Bubblepedia. So this lets us do things like we just write a function that just like, oh, like roll, make a random roll and apply, or like we'll handle it in a more principled way, because we're probably gonna have to care a whole lot about how exactly like randomness is represented, right? But like we can kind of like arbitrarily modify the game state based on like from this function. So hooray for mutation, I guess, and we'll leave it at that, right? So like cool. So we have a representation for moves, right? Now we need this on Pokemon. We probably want it here, right? Like we honestly like, do we just say moves? I think that's fine. I guess the tricky thing is that moves can change, right? Like things like sketch, I guess. But like I don't think that also doesn't matter too much, because like we can just have like a, if it comes down to it, like we'll handle that in a funny way, right? Like because abilities can also change, right? Like things like skill swap or all that jazz. So we'll figure it out. We'll cross that bridge when we come to it, right? Worst comes to worst, we have an extra field that's like overridden ability, overridden moves here. That's like the actual active moves over the base. That's okay. Cool. That's a valid buffer. Yeah. So where do we go from here, right? So I think it's time to start defining how our actual simulation works, right? Sim turn. Or let's be verbose. We're already being verbose enough. So what this is going to do is we're going to take a state. This is one of these battle things. And we're going to take move 1 and move 2, or say action 1 and action 2, right? Because these are not moves, right, that we're passing in here. We're passing in the command that that player issued, right? So things like using a particular move, switching, I think that's all, but like, yeah, probably just those two things. I think those are the only things you can do in general. But it's, so we're not passing in like a move struct, we're passing in like the index of a move on a Pokemon, right? And we'll check validity and all this stuff, right? So what is I wish we had a way to define a sum type, honestly. There might be one. Let's actually see. Emacs Lisp sum type. We want like some kind of ADT. That looks like a Stack Overflow question. That looks like what we want. Can probably, this seems opinionated, right? Like, I just want a way of describing the thing. So we'll just like have a, we'll just use lists, I think. And we'll have something like, let's say, well, no. It ultimately is just a pair of things, right? You can kind of unfold the thing into a struct like this. Let's say action. And an action is a sort, or let's call it a command. Either, let's call it, say, either, I don't know if this is like going to mess up. I don't know how keyword symbols work very well in Emacs Lisp, but let's just use normal symbols. Either move or switch target, either the move index or the bench Pokemon index. Cool, right? So this is going to be, right? So if we're issuing a command to use the second move, right? This is going to be command is move, target is 1, right? We're issuing a command to switch to the 4th Pokemon, right? Command is switch, target is 3. Easy. So to simulate a turn, right? What a turn is there's the current state of the battle, right? Pokemon are out, they've taken damage, there's shenanigans happening, there is maybe some weather effects, right? There's stuff going on. So we have that passed in here. And then each player has chosen the move that they're going to take. And then these moves are going to be resolved based on various rules. Oh, that reminds me, thinking of, we'll scroll up here a little bit. A move, in addition to type power, has a priority level, right? As something like quick attack has priority +1, right? Something like protect has even higher priority, right? There are, and we'll need to use this to resolve the order in which moves are resolved, right? So like, yes, say resolved 10 times fast, but yeah, like we can't, like, we need to determine which move needs to run before we run our effect handler. So that is the thing. So what do we do to simulate a turn, right? So the basic rule of precedence, I think, right? We're probably gonna have to check. I don't know like where we're going to find like the the detailed flowchart of how a Pokemon turn is resolved. I'm sure it's documented, right? Because this is all implemented in Pokemon Showdown, other simulators, right, for decades, and also the game itself, right? Like we can always just dive into the source code again. But it'd be nice if like Bulbapedia had like a resource for it. So maybe we'll spend some time looking for that. But as far as I can understand, the basic precedence is if both switching resolve both switches. I don't know what the priority order is here, right? You would think it doesn't matter, right? As well, you're both switching, nothing else is happening, but it does matter because when you're switching, you can take damage from spikes, right? Which means that the person who switches, if it gets to a situation where, like, I don't know, like, does that matter? Like, can that ever cause a tie, right? Because you can't really switch if you're on your last Pokemon. I don't know. We'll see, right? But like, I think for now we're just going to resolve the switches like in an arbitrary order. But it might matter, right? It might come down to like, well, the first player by precedence, or like some precedence, like based on trainer ID, or like I don't know, the player always goes first, or something like this. It's hard to tell because I don't think the NPCs tend to really switch in, and I have not done much like Link Cable multiplayer or much Gen 3 battling in general. Cool. So if we're both switching, resolve both switches. If one switch and other one move and move is pursuit, resolve pursuit, then switch. If one switch and one move, otherwise resolve switch, then move. If both move, what does that mean? They're both moves. Sort first by priority, then let's just do this. Sort first by priority, then by speed, then randomly. Right. So think if you use, and Trick Room isn't in this game, right? So I think there's no speed shenanigans happening, right? Like you don't ever have to like go by reverse speed, but like you check the move's priority levels, right? If one has higher priority, well, that one goes first, right? If they have the same priority, which will be the common case, right? Because most moves have like +0 priority, I think is the number. Either way, most moves will have the same priority, like the default level. Then you check speed, right? And the Pokemon with higher speed goes first. Otherwise, if there's a speed tie, I think that's resolved randomly. Well, again, we'll check. And I think this is our precedent system. We'll need to comment here. Simulate a turn where action 1 and action 2 applied to ST. Return the new battle state. Yeah. So this is what we're going to do. Let's write that. Do we have a cond macro in this magical world? Bring me back to here. Yeah. So if and eq radius action command 1 say switch. And also the same for action 2. Then we are going to resolve switches. If there's probably a better way to do this kind of casing. Is there a case macro? That's a thing I vaguely remember from Common Lisp. This case table notion. Oh, that's for actual text cases. Very fun. We'll stick with this, right? Like, why? It's kind of repetitive, but like it doesn't really matter too much, right? Equal switch. Well, we need to know if either, right? So like this is, we'll have two cases here, right? We'll have this also have eq. Need some way to get move, right? It's just for now, let's say, and action 2 target move is pursuit, right? Resolve pursuit and switch. Just kind of like blocking out what we need for now. Similarly here, except for action 1. What else? If these are the case, but we are not pursuing, we are made a sucker punch a thing on this generation. Because that is weird. Well, not until Gen 4, baby, right? So I think we can always know priority, like before we can. Oh, well, it doesn't matter. It's not that much harder, right? We just have to like compute the priority based on potentially the other move that's being used, right? Which would make me want to handle pursuit more generally, right? Because then it'd be like, well, we just give switch a super high priority, and we like we're checking the other move's priority. If we're checking what the other move is, like in case we need to handle sucker punch priority anyway, like we can just give pursuit an even higher priority if the opponent is switching. But I don't think it's going to matter. Yeah. Cool. So this is just resolve switch, then move. Yep. And the reverse here. And then finally the last case, which could just be any other situation, right? Because we've handled everything else. We've handled switch, switch, move, switch, switch, move. Now we are down to only move, move. But I don't really want to write it out, because then we also probably want to write a default case. Just, oh, it doesn't matter. We'll just say true. Resolve moves based on priority, speed, etc. Right? What are you? White space. Okay, so it's become apparent that we need some helper functions, right? So one thing that would be very useful is saying Smaragdus action move. Or let's call it let's say action move, right? This is something like we take a team, which team, and an action, and say, okay, when we can do better, we have if let. Is that a thing? Can we if let? We can if let. Yeah, that seems good. Is there a, do we have a when let? Oh yes, we even do, even better. We're really cooking now. Yeah. So I think we can say something like target is Smaragdus. Well, first we'll say when eq move Smaragdus action command action, right? We want to make sure we have a move action, right? We're just going to return nil if anything is invalid, because why not, right? When let target Smaragdus action target. Action. Sure. Do we have other things we want to when let? Team is going to be let's think, right? So we want to look up the team from, we want to get either team 1 or team 2 from, we need to pass ST, of course. We want to get either team 1 or team 2 from ST based on which team, which presumably is either team 1 or team 2. Let's, is there an easy way to append symbols in eLisp? We have to do like the convert to string and then in turn back dance. That looks promising. Okay. Let's team is, let's just pass in the actual thing. So let's just say team is call, let's call this get team to be a little more descriptive. Call get team st. Right. Active is team active team. And what else? Moves is well, we want to know battling active Pokemon, battling Pokemon active. Probably want helpers for all of this, right? But like we'll refactor precisely when we need to. Pokemon is battling Pokemon battling. And then finally moves is practice. Let's write helpers right now actually. Fun practice active Pokemon moves. We'll do precisely this kind of thing. Yep. Moves is Smaragdus. Pokemon moves. Just return this. Yep. Turn the moves list for active Pokemon active. Yep. That's really annoying that it wants to correct grammar that is. Yeah. Let's be cheeky. Let us be very, very cheeky. Cool. So we can fetch moves for an active Pokemon, and then we just say just active Pokemon moves. Right, because as we discussed earlier, right, this might change, right? Later on, the actual moves might not always be just the moves from the kind of base Pokemon. Maybe there's battle specific stuff that we need to do in case sketch is used or other shenanigans, right? So we'll have to think about it. Let's say moves is, yeah, there. So we're just adding this abstraction here while we can, right, before we build too much that depends on this specific thing, so we can tweak it around a little bit later. Cool. We have a list of moves. And we just get the move, I think, right? We just say nth action or nth target moves. I think nth just does what I would expect, right? Yep. So maybe. Why are we even bothering with this? Let's just do that. Given action from team, given a move action from team, return the move data. Sure. Right, so the team uses this action, and the action is a move action. Return our move struct that describes how to use the move. Sure. So now we can say things a little more clearly here, right? Let's find some variables. Oh, and this needs to be when let star, probably, right? That's how you do it. Similarly here. Let indent nicely, yes. One of my biggest qualms with the way Lisp indentation usually happens, especially like the default Emacs thing, is I'm a indentation depending on variable names, etc. Hater, I guess. I do not like aligning things, right? I do not like doing like cute things where like the indentation level here is dependent on the length of the symbol name here. So I feel like it mangles the length of diffs, right? And but I don't know. That's opinion. But I feel like the Lisp style is very like, I don't know. It does that kind of thing a lot. So I don't know. It's small pet peeve. Okay. What are we binding here? We have a few things that we're going to reference a lot, right? We have team 1, which is practice battle team 1 T battle team 2. We have move 1, which is action move, team 1 action 1. This will just be nil. We're not moving. And let's just say command 1. So we're using these a lot, right? And this is getting verbose. Command 2. Sure. You replace all of these things with 1, 2, 1, 2, 1, command 2, 1, command 2. Then yeah, we really did have a lot of these. This is good. This is fine. Yeah. Now we can say here instead, well, those are both switches. Here we're going to check if action move 2 is pursuit, right? Now that's easy. We will say string equals we're going to style these in all caps because I think do we already have a bunch of moves in our strings in our fennel code? We might well. Let's see about that. Move names. Oh, we have all the move names that I ripped from the source code, and they are all in all caps, right? We are going to use that convention because fuck introducing bugs because of that. I do not want to think about that at all. Right, just move name move 2, right? The action 2's move is pursuit, right? And here move 1. Yep, that's certainly a thing we're checking. So now all we need to do is we need a function that resolves a switch, right? So does the switch out, which should be a simple matter of swapping the active Pokemon or one of the bench Pokemon. And then we need the actual damage code, right? Or not damage code, but more generally the move resolution code, right? We want to do lots of things with our moves, right? We want to like we can add varying levels of complexity as we go. We'll probably start with implementing like some simple attacking move that does nothing else, and then we'll get into the shenanigans. One thing to consider. Oh, moves also have accuracy. What What are you? You're opening my carefully placed folds. But move in addition to power has an accuracy. Even pure status moves have accuracy, right? Like Will o' the Wisp has like 75% accuracy, but no power. So we need to care about that. Okay. What else is going on? Oh yeah, and this technically needs like which team, right? Like it's not purely states to states, right? Like we need to know who is using the move. Right, and of course all of this gets much more complicated if we wanted to consider double battles, right? And it gets much more complicated if we want to consider multi-battles. And eventually maybe those things will be things that we consider, but not today, right? And the goal is to make the framework like, I don't know, like I don't want to say that we want to make it general enough that we can refactor it to support double battles and multi-battles easily. So I think that is likely to be so much abstraction that the whole thing becomes very difficult to think about, right? I would like to say that we make the whole thing is short and clean enough that we can gladly throw it away and rewrite it for double battles and multi-battles, because that seems more sustainable. So our goal here today is going to be to write little enough code that is like specific to the single battle situation that we won't feel sad when we have to throw it away if we implement double battles, or we won't feel like we're missing anything super like crucial if we rewrite it, right? We're not gonna be devastated if this needs to be draft 1. So that's what we'll say. All right, let's keep rolling along. I think the next thing to do is let's do switches, right? Let's just write something. Phone. Let's practice. Solve switch. What are we going to say about that? ST. Or maybe we just need to say team again, right? Like a switch is like localized to one team. But no, we need to care about things like spikes and all this nonsense, right? So I'm hesitant to pass. I don't like passing in like the team in addition to the state, right? Because the team is a field of the state, right? So if we're passing in the team in addition to the state, right, we can end up in weird situations where like there's an invariant that there's kind of an implicit precondition, right, that the team that we're passing in is the field of the state, right? And what happens if we pass in some other team somehow, right? Like, so I don't like that, right? I like kind of passing in the minimum information, right, that we need, right? Like passing in kind of extra, like 2 copies of the team. Like it's sort of a mess, right? Because it's not really a copy, right? It's just a reference, but like, you know what I mean, right? It's I don't like this kind of thing, especially if mutation is involved, which it's going to be, right? This is not a pure function, right? This function is going to be making all sorts of changes to state, right? So we want to be real careful. We're in scary territory. The alert music is playing. The guards are looking out for us, and we have to be real sneaky. Okay, we have which team? We have, what do we have? Do we need anything else? We need the target, right? Which makes me think we want something similar to this, right? We want something like Rydus action benched. Action, we'll just call it action Pokemon. given a switch action from team, return the well, do we want that? We kind of care a lot about the index. Maybe not, right? So let's just say this. We'll just take the target, right? And we'll say something like, and the target is just an index, right? Say benched is, or rather the bench is, we get the team first. Team is, I'll call get team st, sure. The bench is Smaragdus team bench team, and the specific bench Pokemon is nth. We'll use, there's all sorts of, there's vectors, there's arrays, all kinds of stuff in Emacs, but we'll just use lists for now, right? Like we are obviously not huge performance enjoyers at the moment anyway, right? We are writing a tree search AI in a text editor extension language, right? So we are far beyond caring that we like about the asymptotic efficiency of our 5-element list lookups, right? Like this is, it's just not going to be super relevant. And if it is, right, we care later. So we care about nth target bench. And then, so we have our benched Pokemon, right? And then we can say something like, is nth a generalized variable? That is very cool, right? So if we say something like, I don't know, def var, let's call this testbed. Our testbed is lists 1, 2, 3, right? We do something like nth 1 testbed. Well, maybe it makes more sense to if testbed is symbols, right? If we say nth 1 testbed, it B, right? We can also do things, I think, like setq nth 1 testbed D. No. Oh, is this setq just takes it takes variables, right? We need to say like setf, right? We need a Lispy set. Yeah. That's what we're looking for. Yep. And then if we say testbed, okay, now bring it back. Now we have ADC. So we can assign to this thing. It's a generalized location, some kind of some exciting common Lisp thing that is very scary to me, right? Like this is the sort of thing like, well, I don't want to use that. Well, actually, we don't want to use that here either. We are brave, right? Because we don't want to mutate our states, right? This is and that complicates things. So we want to return a new state, right? We do not want to just willy-nilly trot all over our existing state, right? We want to maybe have a tree of the states, right, at some point to navigate, right? So let's but it's still going to be a pain in the ass, right? Because I doubt Emacs Lisp has many niceties for doing like non-mutating updates, right? Like saying like we don't, unless we want to implement lenses, right? Which spoilers, I don't want to do. least not right now. We don't have like a great way to say like, okay, here's this deeply nested thing inside of this structure. Give me back a copy with this specific thing changed. So maybe what we do is we do just mutate ST, but we make a copy. Hopefully there's an easy way to make a deep copy in Emacs. Let's Emacs deep copy. Here's common Lisp. Do we have copy structure? Or copy any of these things? Is there a copy? Oh yes. Oh yes, there is. And we need to change our prefix on it for sure. Oh dear. Maybe it occurs to me that defstruct has this conc names thing, right? We had our, bring us back to info, conc name. This adds a prefix to all of the names. Well, it's just for slot accessors, right? Like this doesn't. Is there a copy? There's a copier. Yeah. In this implementation, all copier functions are simply. Well, we probably want this to be nil to avoid polluting our namespace, but like they're just copy sequence, right? Right? Like if I say, let's say def var testbed2 is, let's go back over here. Let's actually create some. So this is Smaragdus stats. Make stats. 100, 100, 100, 100, 100, 100. Right, we got a mu. Oh, it's going to force us to use keyword arguments. That's how keyword arguments work in this setting, I guess. Sure, that's fine. Yep. We have a stats struct, right? If we say, let's say setf testbed2, right? Then if we set up, I think these, our accessors are also generalized locations. Stats HP. Let's set HP to, we're going to change testbed. We're going to set that to 50, right? And if we look at testbed, HP is 50. And also if you look at testbed2, HP is 50, right? Because we like, this is just a reference, right? Like we just assigned a reference. If we instead setf testbed copy sequence testbed2, then if we do the same thing and set this down to 20, then testbed is 20. Testbed2 is 50. So I guess we can just copy sequence these things. Presumably copy sequence also recursively calls copy sequence if this thing is a sequence, right? If the field value is a sequence. So question, or maybe, oh, actually that's not a great assumption to make, right? Presumably it doesn't do that. Let's try and go a little deeper then. Let's make a species. Let's say, let's set this back to testbed2, right? Let's set up or testbed2 to Smaragdus make species, right? It's gonna be number 0, name, Tasmon, type, or we need to number, name, type 1, grass, 2. Yeah, well, we don't need, we just say nothing, presumably. Base stats are testbed. Sure. So let's try again, right? So now if we say setf testbed, so testbed is a reference to the stats that are in testbed 2's stats field, right? If we say setf does stats attack testbed 200, or let's say just, I don't know, I think it's readable, 999, sure. It should change testbed 2. Yep. If we make testbed 2 a copy sequence of testbed 2, sure. And now if we set this, my fear is that, of course, I think copy sequence just copies like the list, right? The sequence underlying this thing, right? Which is just a sequence of like references, right? So like we're not going to deep copy. This is a shallow copy. We can see. We'll set it to 222. Yeah. So we would like that not to change when we do that, because but alas. Alas. So that's not quite what we're looking for. These are, of course, and yes, these are shallow copies, right? We could have just read one sentence longer. Common Lisp close specific things. Sure. Well, the question remains, like, if we do we really need a deep copy, right? Like, do we? Got to think about that, right? Because we fundamentally don't want one, right? Like the copy is just a kludge to allow us to it's funny that my mouth tracking only works. I think the mouth tracking is still kind of finicky because I am I'm doing some janky stuff with VRM in order to make it's just making like the O syllable expression whenever the open C face detects my mouth open. But it only really works, like talking is just like it kind of flickers a little bit. I mean, when I really yawn or something like that, it detects it like that. That's kind of funny. Maybe one of these days we'll have a stream where we dig into the source behind international internet man of mystery LLLL Colonq himself and do some weird stuff. But that's besides the point. So how are we going to handle this? Right? The easy thing would be to deep copy the state every action, right? And then just mutate it, mutate the copy. Then we have our old states still around, pristine, to reference if we need to. But also we have we don't need to do a whole lot of painful stuff to like non-destructively update by producing copies. So what we really want is we don't want a complete deep copy, right? We want to reuse as much as possible, right? Like we want like the behavior we want is like, I don't know, like copy on write for like specific, I don't know. Maybe what we do is again, programmer's first instinct. We immediately give up, right? Let's give up first and foremost, right? And we will write the thing just mutating the state, right? And then we'll think about like what needs to be copied later, right? And either implement a deep copy, because that's like, we know we can do that, and then just keep all the code that just mutates the state and we'll be fine. Or if that's unsatisfactory, we'll throw a bunch of things out and build a bunch of new things. So let us do that. Sure. Yeah. So what does that come down to? It comes down to us saying, like, okay, the new Smaragdus team, the new active Pokemon on the team is, we're going to have to make active Pokemon. The battling Pokemon is the one that was on the bench. The boosts are zero across the board. And the effects, empty list. Sure. This takes a bunch of places, right? So we can double up. And then nth target, Smaragdus team bench team, is the former active Pokemon. So it is Smaragdus. How do you say? Active Pokemon, battling Pokemon. Smaragdus team active team. Well, we want to do this in the other. So we actually need to get active up here so we don't run into some. So our precedence is not all weird. Like so, I think. Yes. Yeah. I think that's it. What does this do? It is resolve the switch for get team to target on the state. Yeah, that seems right. So now we can handle switches, right? So we can replace all these resolve switches things with, okay, Smaragdus resolve switch. To on ST, get team is Smaragdus battle team 1, and the target is, let's have just some of these. Target 1, target 2, action target, action target. Target 1. Target 2. Yep. So that'll do it. Still not satisfied with this like thing. I think it's probably just fine to pass team 1, team 2, right? I don't like it, but that's the way the cookie crumbles sometimes. Not the cleanest. And we'll ignore state for now. But we might need it because again, those spikes situations we will possibly have to care about. Maybe not. Maybe it's even cleaner to handle that outside, right? Like that's, who knows? Maybe we have a handle spikes for both. That actually sounds appealing. Well, no, we want to have a generalized switch thing. Takes care of all that nonsense. So, sure. Sure. Resolve. We'll just leave this to resolve pursuit, and then we are switching for team 1. Resolve pursuit, and we're switching for team 2. This is set resolve move. Resolve move. This one is team 1, the other one's team 2. Yeah, okay, so now we are handling switches. Unbalanced parentheses. How dare you? Where have our parentheses become unbalanced? Somewhere in here, clearly. That seems right. Yep. So, onward, right? We have switching in theory, right? We haven't tested any of this, right? Like we'll probably test. We'll start playing around with it a little bit in the near future. Why is our window so short? Debugger, I guess. Cool. What comes next, right? Resolving moves. I sort of... Let's make a sort of shim handler that let's call this resolve move. St us them target. Us them move, right? This is nice, right? Resolve move used by us against them on st, right? This is, so us is the current, like the person, the team using the move. Them is the team that's the opposing team. Move is the move struct, and st is the whole shebang. In case we need to care about things like rain, right? Like rain is going to influence the damage of the move, right? It's not specific to a team, but we still need to care. And of course, we're going to be mutating st. Sure, right? And we need to make sure, since, okay, if this mutates team, right? We need to make sure team is, if we're doing deep copies, right? We do the deep copy before we do all this nonsense, right? It's actually all this new st. Right now it's just st. New copy, maybe. We will. New st. Use st anywhere else? Yeah. Use it a lot of places in all our resolve switches. Oh. Any more? Okay, we're good. Let's explicitly call this old ST, so we don't have an ST in scope that we accidentally use. That's fine. Sounds good. Okay, so now move resolution, right? This is after we've determined priority, but before we've actually done anything about it, right? So we haven't actually, like, this is where we do damage, this is where we apply the effects, right? So for now, let's just get, say, okay. Say their active is that. Let's set f Smaragdus active Pokemon battling Pokemon. They're active. These names are unwieldy, but that's how you do it sometimes. Smaragdus battling Pokemon current HP is what we want. We're setting that to they're in DECF. That's a common Lisp thing. Yeah, not a particularly useful thing. Their HP is this. Let's do the whole song and dance. You're battling. Sure. So we're gonna set current HP. They're battling to minus their HP 1. So for now, we're just going to subtract 1 when we use any move. Yes. Ignore ST us move. It's fine. It's all fine. So what's the deal with that? Let's put this into a context where we are calling it. Let's just say if we're both moving. Well, let's not do priority stuff yet. Let's just do, let's right now just put these in a random order, or just move team 1 goes first. This takes new ST, team 1, team 2, move 1. This takes new ST, team 2, team 1, move 2, right? Because this is us, this is them, this is the move that's being used. Yep. This is a team 1 move resolution. This is a team 2 move resolution. This is a team 1 move resolution. These need to go first, of course. Team 2. And if we're both switching, we don't need to. Okay. Order. Yep. Okay, that's a little something. Now let's build a test battle and start seeing if any of this stuff actually works, because it probably won't the first time, right? Like, let's see. Test. Let's just call this, right? Sure. And we're going to be typing this a whole lot. Is this going to collide with anything that we care about? Is this? Yeah, it's not. So we're going to use this because we are brave. Make battle. Yep. Team 1, Team 2. For all the marbles. Team 1 is practice make team. Let's make some test species too, right? And let's make them actual Pokemon because that's fun. What's some good Pokemon, right? Do we have what can we do here? Let's say what can we do? We want to have just like a big A list of species. That seems useful, right? I don't know. Something like that. By number, maybe, or by name. That seems like it's potentially useful. Okay. Let's say 1. Make species. I'll just have just a big list. How about that? We can look up just by searching. Number 1. Name. Or type 1. Grass. 2. Nothing. We don't need to type 2. Let's see if we can get some stuff going on here. We open a new window. Do I have some weird shit happening? I have an extension that turns new tabs into new windows because, like, as you can see, there's no, this is just Firefox, right? But there's no like user Chrome, right? There's nothing visible. That is so I can't switch tabs very easily, right? And I just, since it's EXWM, I just normally just navigate between windows as the corresponding Emacs buffers, so it's much more convenient to have everything in a new window. Maybe my extension is not. Actually check that. We have dtab on. Oh, should be working. Who knows? Who knows, brother? Either way, how did we end up here? We closed that window. Oh yes, we did, because it was opening the. Oh, well, this is all fucked up. We're gonna have to do all sorts of fuckery here. Maybe our settings are off. No, we don't want to do that. That's gonna be even more confusing. I don't know. So our detabifying extension is currently kind of fucked. So, but what can you do? Bulbasaur. Let's get your stats. Do we have no, not from the anime, the games. Overgrow, sure. Make stats. What are your base stats, Bulbasaur? What will they be? Okay. HP 45. Attack 49. Defense 49. 65. Sure. What are you? I mean, ability 1. Here we go. Okay, so we have our species. We have Bulbasaur. We can say make some Pokemon, right? Let's also say we have a test Pokemon that is make Pokemon. Oh, we don't need a name field on Pokemon. Smaragdus, make. We just need a nickname, right? Because the name is going to come from the species. So nickname is Dudeweed. Gender F. Dudeweed is a dude, bro. He's it's an M. We're gonna stereotype him a little bit. Species is nth. All species 0, right? Sure. That's our indentation all fucked up. Maybe we should align these so it's like we have an explicit nil, so we can say just look these up by their number. That's nice. Okay. Species is such. Level will be 50. Ability will be. What do we say about abilities? Species. Ability 1. Our nature is jolly. Dude, we is very jolly. Then we have IVs, which will be all 0. Or let's make some of them 31. Just so we have something to mess around with later on. EVs will be all 0 except for these, which are 255, 252, I don't know, something exciting. Is that all that we care about? We need moves, yes. Moves. We're gonna need some moves. Inc will have just one move for now. And that move will be something like this. We'll just make the move right here. Asparagus. Well, let's make a test move. So I expect we're going to be using it a lot. Make move number 0, name wonk. Type is normal. Type is fighting. Priority 0. Power is 10. Effect is oh, hey. Thank you so much for the raid. That's very kind of you. Welcome raiders, welcome Spooksy VT. I hope you are having an excellent stream. We are doing some shenanigans, right? We're programming some Emacs Lisp. We are trying to write an AI to do battles in Gen 3 Pokemon with the eventual goal of integrating with an emulator to, I don't know, maybe play Pokemon Emerald, maybe do Battle Factory shenanigans, maybe go on Showdown a little bit. I don't know. Thanks for the compliment on the model too. It's yeah, it is actual text, right? So if I go, let's go narrow mode. Let's get narrow, right? I get all squished. Right? We are going full ASCII. So cool. Thanks again, and hope we can do something interesting here. All right, so back into it. We don't know exactly what our parameters for this are going to look like yet, but I think we'll say st team and then nil, or say st. Oh yeah, thank you. It's I actually wrote the let's do something model related because we're talking about it. Let's where can we go that will make things, let's go over here. Let's go to over here. I'm going to disappear for a second. And let's do something exciting. The rendering is all custom, right? So we can actually change the text that's behind the thing. That's gonna opening. So let's see. I want to make sure I'm not accidentally launching my Rust LSP because that's going to use a lot of shit. I don't think I am. Okay. So the current text is this. We can make it say, let's say, hi Spooksy VT. And then if we relaunch, take a little minute to compile, and maybe we will end up with something that is a little more agreeable. Let's see. Taking a minute. We'll watch over here. See if things are going well. Maybe they are. I'm streaming from a very, very old laptop, so sometimes things like to take their sweet old time. There we go. Okay, we're building something, compiling some code. Maybe we get there. Let's click over here. So we're. Oh, don't worry. This is. I think we're in the. It's. There we go. So here I am without my my ASCII mode, right? This is a little custom renderer that like handles the face tracking and animates this thing. It's got mouth and eye tracking. If I go over here, right, looks very different now, right? Background text is I don't know how clearly you can see on stream, but I think it comes through. So yeah, we can just change to whatever we want. So yeah, I think I'll probably want to integrate this with like I don't know, like channel point stuff in the future if that future ever comes. But do all kinds of nonsense. Cool. We gotta manage our windows here. There we go. Yeah, thank you. All right, back. I think we're gonna get back to business. Let's delve back into the magical world of Emacs and Pokemon related topics. I'm gonna keep this background as thanks for the raid. This is the first raid, so you have the dubious honor of being the first ever raider to LLLL Colonq. Cool. So what are we up to, right? For now, we're gonna have a test move. Let's just say nil for the effect, right? We won't get too ambitious. What are we complaining about? Effect. What is that? Thank you. Is a as I said, a dubious honor, but if you accept it, then I'm glad. Why are you complaining? Keyword argument effect. List witness. What is? Have we not? Okay. Move. This should be here. We not evaluated that. Do we have a Smaragdus move effect? We do. Okay, we just hadn't rebuilt. Let's actually eval buffer just to make sure everything is up to date. Yeah, and then okay, so we have a move. The move right now is just going to be test move for our Bulbasaur Dudeweed. What is complaint? Keyword argument. Oh, we need duh. Okay. So our team on one side, let's actually call this Testmon 1. We will also have Testmon 2. This bro. Similarly, what are Pokemon natures? It doesn't matter for now. I'm gonna say rude. Same IVs and everything, same move, but like it's a distinct thing. So if we edit it, right, we're gonna end up with we're not gonna be running over each other. Well, I guess these shouldn't change anyway. I mean, that's why we have the whole like active battling Pokemon abstraction. Oh yeah, awesome. Thank you. Have a good rest. I hope your stream went well. I will definitely check out the VOD. I'm always looking for VTubers to watch. Cool. Let's say make team. Our active Pokemon is going to be what will it be? Make active Pokemon Magnus make battling Pokemon. Pokemon is Tesmon. Item nil. Current HP 100. Status nil. Sure. This is the and we say the boosts are this sort of thing. Stats struct. And the effects are an empty list. Yep. That seems right. Oh, and the bench. Who's on the bench? Bench is a list, right? We do need another Testmon because we need something to switch out with. So this will be Testmon 1. We will also make Testmon 2. Bro. That'd be rude in nature. Let's capitalize our things just to be funny. Same IVs, same move. Just so we can tell them apart. And that's just the bench is just a single battling Pokemon. I have to re-indent that, but Tesmon 1, Tesmon 2. Yeah, so that's the team. Team rolling out. Okay, so team 2 is going to be exactly the same. But maybe we make the HPs all different, right? This will be 100 and 1000. This will be 200 and 2000. Right, so when we see the HPs, it will look like something. Let's actually make this 222. So if we subtract some numbers from it, it looks kind of reasonable. Similarly there. This needs to be team 2. This needs to be 111. Sure. Sure. So this is, we're making a battle. These are our two teams. What else do we have? We have weather. Well, it's going to be nil. Effects, let's make that an empty list. And that's the whole shebang. Variables nil Testmon 2. Need to make sure we are evaluating things. Cool. Okay, so now we have this ST, right, which is a giant state structure that has a bunch of testing data. And then we can hopefully simulate some turns on this thing, right? And we can see what's happening there. I think before we get into that, I'm going to briefly go BRB to grab some more water, maybe a little snack. So I'll see you in maybe 2 or 3 minutes. Cool. I'll be right back. Enjoy the blue screen of death. Windows crashing noises, dial-up sounds, assorted soundboard effects. Engage now. Go. See ya. All right, water has been obtained and piss evacuated, so it's time to get back into it. So where did we leave off? I think we left off with we defined this test state, right? So we have a test battle all set up between the brave forces of Team 1 and Team 2, both who happen to have identically nicknamed Bulbasaur. And let's see if we can make things happen. So I guess first let's test, like, maybe just resolving. You know what, let's just go bravely forth, right? Let's just try and run moves, right? Like let's say Smaragdus simulate turn ST. What's action 1? So action 1 is Smaragdus make action command. Let's just switch them both out. Or let's make something to show. I just want to get the active Pokemon for each team, right? We want to say Smaragdus team active battle team 1 ST, then let's add a little helper function for this, I guess. Defun team 1 active name ST, and that will just get battle team 1 ST, and then Smaragdus team active that, and active battling that. We'll do a little bit of indentation just to not ruin our eyes. And Pokemon of that. And then Pokemon nickname of that. Yep. So then we can say team 1 active name ST. As expected. Let's actually swap these two, right? So they have different names as well as all the other jazz. So the same for team 2. Team 2 active name ST. Oh, rude. It's because I didn't change the name. Let's redefine both of them. No, not that. That. Yep, so we have Dude, Weed, and Bro. Okay, well, let's try and execute a switch. Can we just say, let's just do it with the resolve switch command first, right? If we say like resolve switch ST, and we need the switching team. So let's try and switch just team 1. Make this battle team 1 ST. And we're going to switch to, the target is just going to be 0. That means it's just the first thing on our bench. All right, well that gives us back whatever resolve switch returned, which is not super useful. But now if we say team 1 active name, we get Bro as well, right? So we've done a switch, it looks like, right? If we do a switch again, here's the real question. Do we get back? Yeah, so we can switch back and forth. That looks like it works. It seems like a reasonable thing. So let's try some more stuff. Let's see. What about moves, right? So if we have team 1, let's have team 1 use bonk against team 2. So if we say all this nonsense, let's add some helpers to get HP as well. Let's make this team 1 active HP, right? This can be battling Pokemon, current HP, lose a parenthesis, I guess, and then this can be team 2. These are not functions that are sticking around, these are just functions for interactive use, so I don't have to type, like, whatever, a whole tweet worth of characters to just check the HP, because it's I'm sure we can look at it in here, but this has like fields elided and like it's a pain in the ass. Really what we want is we want like a buffer that just like in the long run we'll have like buffers that display these things, and like we can have better tooling, but the basics come first, I think. Oh, it's I'm looking at my model here, and it's very cool how different it looks. Much more angular because of all the V's and K's. I think that'll have to be a future lab project. We're gonna we'll do that on stream. Integrate the model display with the Twitch bot. Anyway, doesn't matter. We're resolving a move. We're resolving a move as team 1. That's us. Against team 2. That is them. And the move is to get the move. How do we get a move again? Up here and simulate turn. It's an action move. I mean, that's such a pain in the ass. Probably should not have built our. Well, it's fine. It's all fine. Let's just say we're using test move, right? Because moves aren't mutated, right? It doesn't matter, like it's all, they're all just references to test move anyway, so it's okay. That sure looks like 222 minus 1, which presumably is the last thing computed by this function. We should clean up the return values too and make them return something sensible. Nil probably. But yeah, if we check team 2 active HP, yep, we do it again. Yeah, so this is bonking the opponent for 1 damage each time, because that's all our current move resolution code does. Let's switch again. Let's have team 2 switch. So team 2 has switched. Team 2 now has 2,222 HP. Let's bonk them again. Yep, they've been bonked. And now if we switch again on team 2, the sticks around, right? So this looks like a lot of what we want, right? We can switch Pokemon around. We can resolve moves. Yeah, that seems cool. Let's Oy. I don't know why I stream so darn late, but that's the way it is. So there's no point bitching. Let's try using simulate turn then. So rather than just directly doing this resolve switch thing, let's actually say, let's make sure that switches happen before damage, right? So currently the Pokemon on the bench is at 2221 HP, right? So if we have team 2 switch. Let's make an action. So team 1 is going to use an attack. Use the first move, right? Team 2 is going to switch to the first Pokemon, right? So team 2 currently has this one with 220 HP in. We would expect the resulting state of this to be the switch resolves first. The Pokemon with 2,221 HP comes in. Then we hit for 1 damage. Is that the case? Looks like it is, right? Team 2 active HP. There. Team 1 active HP shouldn't be changing. It's not, right? So, this looks sensible. It seems like the kinds of things that we want to happen are happening, right? We would be kind of surprised if they weren't. All this code is pretty simple, right? Like, apart from like the things we're always worried about with mutable state, which is like, well, we have a reference. We're keeping a reference around twice, and we're mutating it in different. Like we're not properly keeping track of copies and references, right? That's one danger. But like I think we've been careful enough about that, and I think like mostly we want the thing to be like big parts of the whole thing are immutable, right? Like, and we've done a reasonable job of splitting things off to where we need them to be. And then this kind of priority thing for switches is pretty nice. So now what we really need is to, well, we have 2 directions to go, a fork in our path, if you will. We can either move towards properly resolving moves, right? Like right now we're just saying, okay, deal 1 damage, right? We can do things like, I guess we have 3 paths, right? Because we can properly resolve moves, by like computing their damage correctly using the big Bulbapedia damage formula of despair. This thing. We can handle the consequences of moves correctly, right? So beyond just damage, we can handle effects. And another kind of like side effect of damage is Pokemon fainting, right? Which we can go well into the negatives here, right? Like we could just keep pressing punch bonk for 1 damage until we're at negative 1,000 and nothing's going to happen. So we need to handle the case where HP reaches 0, and then we have to faint, and then at the end of the round there has to be a prompt for a new switch in, right? Which is like a special type of turn, right? This is like a fancy kind of thing, right? We hadn't even thought about that, right? That's it's a whole separate sort of action in our architecture. We'll probably, how will we handle that actually? Let's maybe go on a side think here and think about how we're going to deal with that. So I think right, switching in after something is defeated, that's sort of like it's a turn where only 1 player is acting, right? So like maybe we model it as it's like a normal turn, but like 1 player's action has to be just do nothing, and the other player's has to be switch. That seems reasonable. And then what we'll do, okay, I know exactly what we'll do. We'll have a flag on the global battle state, right? That indicates, is one of the Pokemon that's currently active fainted, right? If that's the case, is we're going to have to do something eventually to compute the set of valid moves, right? That you can make. So if this bit that says if one of the Pokemon is fainted, the only valid move that you can make is like the player with the fainted Pokemon switches, the other player has to do nothing. Which means definitely going to have more types of moves, right? So we're definitely going to, like, let's explicitly check here, right? That's a source of potential future frustration that we can co-opt right here. Let's make sure these are actually move. So we don't burn ourselves if we forget a case. Like, let's explicitly enumerate like what case we're handling. Then what else? What else? I guess the other side quest we can go down is we can actually handle priority, right? Like do the priority math. And that's probably pretty easy. I think actually the most critical thing for us is going to be the fainting logic, right? Because that's going to that's kind of like the thing that's most architecturally interesting, right? Like things like damage, like computing the damage. Well, we had 1 and now we have 100. Like it's just we have 85. It's just a different number, right? Like it's not like kind of qualitatively different. And similarly with your priority, it's just all it's going to influence is what order we run these 2 lines in. Well, I should have, let's highlight the line. Yeah, what order we run these lines in. So that's also like, well, while fun, not going to be super architecturally interesting, but like the fainting thing is, right? We need a way for like players to choose what comes in after something faints. Okay. What shall we do then? Let's handle that fainting situation. Let's and of course, well, and the fainting situation does not always prevent the opponent from doing something, right? Let's note that, right? It prevents the opponent can also, if for example, if you use explosion, right, and both Pokemon faint, right? How does that actually work? Right? I don't know if you choose simultaneously or if one person chooses first, right? I know also that explosion's precedence rules have changed generation to generation, right? In some generations, if there are only 2 Pokemon left and one of them uses explosion and faints the other, like in some generations the exploding Pokemon's team wins, in some generations they lose. So let's think about that. Let's see. Maybe there's information here about precedence. Okay. Yeah, in Generation 5, the user faints before dealing damage. That's the new thing. Gen 3, not so much. I still don't know. We'll have to have some special logic for like handling the winner, I guess. Yeah. How are we gonna deal with this? Well, either way, regardless of any of this, we have a new action type, right? So instead of just move or switch, we have one of move, switch, faint switch, I think. We'll call it that. Well, the thing we really want to know is Pokemon Gen 3 simultaneous switch. Well, we don't want to, we're going to hear a lot of things that we don't care about. switch. I wonder if Smogon has information about this. They tend to sometimes have that. Might go on a deep dive onto Smogon. Okay. Thank you, Luigi, Mr. Smogon moderator from 2017. Okay, so this is actually something like sort of related to what we were talking about before, this switch priority thing. The person who acts as player one, when I was speculating that maybe it has to do with like trainer ID or whatever, but I guess during what do you say, like link battles, it's just based on the player number in the link battle, and it does matter, right? They mentioned this intimidate case here, right, which I wouldn't even think of, right? Like whoever switches in second gets intimidated, so it matters. That's kind of funny. So in this, I mean, clearly, I mean, playing on simulator, I guess it depends on, they use custom rules, right, that bases this off of speed ties, like, or like bases off of like actual speed. That's weird. Yeah, and that does leak information about speed, right? Because then you I don't think Choice Scarf is in this. Choice Scarf in Gen, I think only Choice Band is in Gen 3, but like either way, you could, if you're running like unconventional, like an unconventional speed tier, like, or some, if you're trying to beat a speed that is unconventional, or like hide information in general, the switch in thing can reveal that before the first move. Gross. Yeah, and there's a universal turn ends when Pokemon faints. I wonder if there's good documentation on the, let's see if we can get something special. Hold on. Gen 3 mechanics. It's going to give us RNG mechanics. This is just specific move scenarios. Mostly. Well, all this stuff matters, right? Because we really want to know how to handle re-switching on a feint, right? Like, and I can imagine two separate scenarios, right? Like, the common case is where only one Pokemon is feinted, right? And then, okay, so that player then has to switch just immediately, and the other player can't do anything for that quote unquote turn, right? Because we're going to model a switch as like kind of a turn, because it is kind of a turn in the context of the game state tree that we're trying to model here, right? Like it's an action that involves choice. The player with the fainted Pokemon has to choose to do something. The other person just waits and can't respond. The issue then is, like in the case of like simultaneous death with explosion, right? Which is not super uncommon, right? Like explosion is a common move, right? It's, I think, from my understanding, I have not played very much competitive Gen 3 Pokemon, but like I think Metagross is like one of the defining Pokemon is like Metagross and Tyranitar or something. And Metagross like runs explosion. I think explosion is like I don't know if it's a TM or a move tutor in Gen 3, but like it's accessible. Like fainting something with explosion is common, right? So like this situation will come up. What I expect happens is, okay, you use explosion, the opposing Pokemon faints, the opponent picks their thing to switch in, and then your Pokemon faints, and you pick your thing to switch in. So it's sort of like, it's two distinct turns, right? However, this poses a problem for our effect resolution, right? Because what that means is our effect resolution is kind of spread across two turns, right? In the sense that like the effect of explosion is faint the user, right? But the user faints like kind of naturally after the opponent has already made their switch, which is like another kind of like pseudo turn. So maybe the thing we do is just we explicitly track the fainted state, right? So beyond just like checking like, okay, does the active Pokemon have 0 or less HP, right? Current HP. Instead, what we'll do is we'll have like a flag attached to the battle state, and that flag will say, will be, I guess in general, like the thing to do is it'll be a list of who fainted, right? In what order. So normally that list will just be one element, which is the Pokemon that fainted. In the case of explosion, right? It will be like both. That makes sense, right? And then we'll just check like when damage is dealt, right? We'll just have a general, we'll just have something in general that checks for faints. So given a state, just update that fainted flag, right? And then we'll only add to that fainted flag. It's kind of a fainted queue, actually, right? We'll add to that fainted queue whenever we observe the game state and we see that an active Pokemon is below 0 HP, below 1 HP rather, and is not already in the queue, and we'll only remove from the queue. We'll pop off the front of the queue when we're handling the faint switch thing for that team, right? Okay, so that, I think that's a reasonable architecture for handling it. It's still like, I mean, it's fine, right? Like obviously the faint switch action is contextual, right? You can't take a faint switch all the time when you can generally move, or you can't, but you also can't move all the time, right? You can't, like saying move 3 doesn't make sense in a lot of states, right? If your Pokemon only has like 2 moves, right? You can't use the 4th move, right? Saying switch anything when all of your other Pokemon are fainted, right? You can't, that's not a valid move, right? So already the set of moves is already very contextual, or the set of actions rather. So like having the faint switch action be contextual and the context is, okay, your team must be at the front of the fainted queue. That seems fine, right? That's okay. I'm convinced now. I've convinced myself. I think we're going to handle this. It occurs to me that an interesting way of getting good information about them, like people play like Game Boy Advance like metagame competitively, or at least they discuss it, right? Like I've watched some YouTube videos recently about the GBA metagame and people climbing Smogon ladder and all this stuff. So like presumably there are people who know about and care about these things. So maybe that's some off-stream homework for me to delve into some the murky recesses of Discord and see what I encounter. But for now, we're gonna continue making assumptions that may or may not be proven wrong in the future. All right. So where do we start? Where we begin is we're going to need to we're going to call this painted queue. We're going to give it a default value. We're going to start giving our, these don't want to be nil, they want to be, there is a difference between, the whole thing fucking sucks, right? Is there a difference between empty list and nil, right? I mean, they're not eq, right? Obviously. They are eq. Well, I think it doesn't matter. It probably just doesn't matter at all. My brain is so hopped up on assorted Lisp dialects at this point that I never remember what semantics are which and what, and it doesn't matter. The general rule probably is like most like very niche like technicalities or like, I don't know, minutia of languages, if they're difficult and like complex and like if they're difficult to remember and complex and like have like weird mechanics, right? Like relying on them probably isn't a good idea in the first place, right? I would rather than like learning the minutia of like eLisp, common Lisp, closure, like scheme, fennel, every other like Lisp I'm using, or just language in general. I mean, it doesn't really matter the syntax. I would rather kind of get comfy with common patterns and not spend a whole lot of time learning annoying minutia about some implementation detail of the thing. Yeah, so rant over. We have a fainted queue. The fainted queue describes the order in which Pokemon have fainted. Sure. How do we handle the fainted queue? Right, well, we have a update fainted helper function. Update the fainted queue of st. What this means is if a Pokemon is fainted in the current state, notably we can call this on intermediate states, right? Such as in between applying the damage of explosion and the effect of explosion, then also after applying the effect of explosion. If when, let's say, and we gotta do some shenanigans here. When let we gotta get some shit going. Team 1 is battle team 1 st. Team 2 battle team 2. Active 1 is the team active. Team 1 to 2 is this for active 1, and similarly for active 2. All that stuff. Then we're checking when, and you know what, we're gonna go one step further. We're just gonna go all the way. Excuse me. Getting the Lisp hiccups. HP1 battling Pokemon current HP, yeah, battling 1. This is all very verbose. right? These things, like, in a perfect world, we'd be saying, like, st.team1.active.battling.current HP, right? This could be, like, but we do what we do, right? We could write a macro or something. We could do all sorts of things to make this experience probably nicer, but it just doesn't matter that much. It's just not that important. I don't think it's critical for our experience, right? Let's focus on the schmeat. All right, so we have HPs. When and HP1 or less than or equal to HP1 0. And also, what are we checking for? We want to make sure, so we're adding to the queue if we're not in the queue and our HP is less than or equal to 0. So how do we check if something is, use, there's probably a built-in Emacs function, but I like there's this dash.el library and s.el that kind of have, make the names a little more consistent. Yeah, so we give it the list, which is Q is battle fainted Q st. Yep. The queue contains team 1. Can we push? We can push. We need to say not contains. So if we ran out of HP and we're not already in the fainted queue, this will push to the front probably, right? Yep, that makes sense because we're consing, right? But we're going to be checking the back. The eternal annoyance of using using a console linked list as a queue rather than a stack, right? I think there's a better queue. You can use a better queue representation if we have 2 console lists, right? And we kind of separately keep track of the list going forwards and the list going. I don't know. It doesn't matter here. This list has at most 2 items, right? So like, we don't need to really care about like the asymptotic performance of like lookups in this thing. Like it's all a constant factor, baby. It's all gravy. So we're gonna push that. We're pushing team 1 to Smaragdus battle painted. Because remember, this is we can't just push it to Q, I think, because while Q refers to the same list, this is right. Like, I think that what that would do is it would just simply update the local variable Q, right? Like we're trying to update the actual entry in the struct to the new cons. So that's cool. Let's do the exact same thing for team 2. Right? So if the thing's actually fainted at the same time, and we have not called, like, the intention here is that we will call update fainted frequently enough and in the correct places such that both of these are never true at the same time, right? Like in the case of I think explosion will be the most common case, right? Maybe like, I don't know, simultaneous death to status conditions or sandstorm is another possible case. But we can deal with that, right? All we need to do is make sure we're calling update fainted like between dealing the sandstorm damage to both Pokemon. But if in the case where we like actually do have an update on both of these, like we could I guess detect that case and like error, but we're going to choose to self-sabotage and just kind of silently succeed and do something that's probably wrong. So that's okay. Neato. Yeah. So we can update our fainted queue now. And then we'll add another thing, another function that's called has Pokemon fainted, and return the Pokemon that fainted first in ST. Okay. Or nil, of course, right? We have an implicit option type on everything here. Everything is maybe a. Sure. Okay, let's think what that looks like. This is just the last element of the fainted queue. Cool. Or return the team fainted first. As team fainted. Yes. This is the list. This is a list of the symbols team 1 and team 2 in some order. It's not the list of Pokemon. Sure. If we say last nil. Why is last complaining? Oh, last takes a predicate. We want the actual last function. Silly me. That does everything we want. This as team fainted. ST. For good measure, maybe we throw an update fainted in there. No, I don't think we need to. That's getting a little. This is a pure function we have right here, and we don't need to make it any nastier than it already is. Let's then say, okay, we need something to actually remove items from the fainted queue, right? We could pop from it, or it's easier just to do a like remove, right? Make sure there are no fainted. Well, we'll do it. What we really want is this. We want Smaragdus resolve fainted switch. ST team target. It works much like a normal switch, right? In fact, exactly the same. Except first we are going to is this destructive? Turns a new list. Huh. We have a what is filter called in Common Lisp? That's some awful name, like remove if or something. We don't even need a predicate. We just need to remove, right? Need to remove. This also returns a copy. I want delete. Delete members of Seek that are equal to LT. Yeah, that's exactly what we want. Yes. We want this on. We want to delete. Oh wait, well, here we have we're passing in the actual team. We don't have the team index, right? And the team symbol. How pleasant. We'll just pass them in. And the reason why I am putting all of these variable names in the doc string is because otherwise we will get a complaint. And it is easier to put the variable name in the doc string than to make the complaint go away through I don't know, extrajudicial means, let's say. So we're removing team sim from just battle fainted queue. ST. We're doing that first, and then we're going to resolve switch as we would normally. And the reason for this is that the reason why we're doing the remove from the fainted queue first, we have to make sure to do it first, is because as soon as we're resolving the switch, right, like the new Pokemon that switched in can faint immediately, right? Because presumably we're eventually going to have some logic up here. We're ignoring state for now, but eventually we're going to have logic to handle spikes and stuff like that. Entry hazards. I think spikes is the only... Toxic spikes exist in Gen 3, probably. But there's potential, like it's possible to faint immediately. So we want to make sure that the Pokemon is removed from the fainted queue, because the result of the switch could be like need to switch again. So yeah, let's make sure we're handling that properly. Okay, and then what we're going to do is the actual prompting to make a fainted switch move will occur in the, like, it'll just be, we'll be generating a list of the valid actions, right? And it'll just be the only valid action when the active Pokemon is, when the fainted queue has an entry, when has team fainted is true. And then I guess we just add logic for it here. Okay, let's say, okay, if eq, is it called faint switch or fainted? What did we decide to call this thing? Jesus Louises. Let's call it that. Sure, that's fine. So if command 1 is fainted switch, regardless of what command 2 is, we resolve the fainted switch. Make sure to pass that symbol in. And then similarly for command 2. Bing, bang, boom. Okay then, so now we just need to make sure in places like this, we call, whenever something could faint, we should try to call update fainted. What are you whining about? Oh, we're in the S setup. Sure. Yeah. Like so. There we go. So let's eval the buffer just to make sure. Let's make this do 100 damage instead. So we can say, we can now say more interesting things. How are we dealing damage? Where's our, I just want to hit bonk, right? So we can check team 2 active HP. Well, let's have team 2 switch. Switch. Yeah, team 2 has switched. Team 2 has 220 HP now. Bonk. So now team 2's active HP is ST, right? So the fainted queue should be inhabited. If we say battle fainted queue ST, it is not. Why is it not? What is going on here? What is that business all about? If we just explicitly say update fainted ST, we got nothing. We got nothing. Let's make sure, let's have some messaging. Let's do that. Nothing. Just printing things incorrectly. Team 2's active HP is so. Is this how? Is this true? That's true. Well, let's start printing at the queue. Why are we not doing printing the queue? Oh, one of these things is nil because we're using whenlet. I see how it is. Oh, it's because queue is nil. Because queue is an empty list. Let's do that. That seems better. Source of our woes. Sure. So 2 has fainted. So now the thing updates properly. Sure. If we look at the fainted queue, it's just team 2. So yeah, I think that works. That's kind of nice. I think things kind of line up nicely there. We have the logic for handling the painting in place. We just know now that well, there's this fainted switch move type, and we're going to know that that move type is only valid when the user's team matches has team fainted. So good. Do we want to continue? Let's think. Well, I think perhaps we will. Let's make an attempt at least at adding some damage code. And then we'll hit the sack, right? We'll or I guess priority isn't bad either, right? Priority is easy. Right, let's do priority right away. Super easy. Where is that? Where are we going here? Here, right? So what's going on? We have a cond again. If okay, we need to go up here. We'll keep track of the priorities. Oh no, we already have the moves, right? If I just move priority of move 1 is greater than just move priority 2. That's the condition. Then we do move 1 first, we do move 2 second. Otherwise, if it's less, we do the thing in the reverse order. Sure. Otherwise, they're equal, in which case we instead check the speed. So in this instance, right, we can't just check the speed stat, right? We need to actually compute stats, right? So this is maybe a little more complicated. Maybe let's, you know what we will do? Let's wait, I've been going for 3.5 hours. I'm going to pass it off to somebody. We will pick this up at a later date. Maybe even tomorrow or the next day. And we will continue. We'll do calculation of stat boosts and then also damage and priority. And that should give us a reasonable simulator. And then we can look at grabbing data for Pokemon and like testing some teams against each other. And the most important thing, which is going to be like getting move effects working. But I think our framework here is general enough that like we can probably do that pretty easily. Like we just have like arbitrary eList functions for the move effect, and like I think we can probably handle the corner cases relatively well with our little effects tags system. So like, yeah, I don't know. We'll see. I'm sure there's some sneaky bastards that are kind of hard to handle. So yeah, let's see. We got 4 viewers. Let's test the raid functionality again, and see if the raid number is greater than 1, and we'll see if there's anyone who's looking promising to raid. And, what are we looking at here? What's the list looking like? We have Corpse live again. What is Corpse up to? Dragon Quest. Let's see. Will we raid with more than 1 person? We won't. We will pass for the day then. Cool. Well, it was very fun to talk with you all for another couple of hours. I think we will we'll pick this up in the near future. Maybe with some breaks for the long-awaited lab stream where we build a Twitch bot, so we don't we have some notifications for things, and we can integrate a little more with the model rendering and et cetera, et cetera. But yeah, we'll pick this up shortly, and eventually this side of things, the brain, will be integrated with the arms and legs of the emulator interaction, and we can run the whole shebang. So cool. Well, in that case, goodbye. I'll see y'all later. Bye. I have to find the thing to click, the button to press. There it is. Goodbye. Now, going, press, go.